Great. So right now we are on the binary search 704 from the Leet code. Basically, I copy the answer from the Nick White channel. I'll provide the link in the description. And then I create the test case based on the Leet code input, and I just run it in my IDE, so I can know what happened on the background. As the Leet code provided, we have an array which is a target of 34, and how does the binary search 704 work in this code? So first of all, we need to make a breakpoint. This is like where do you want to stop for the debugging. Back to the test case file, and then you just click the debug. So you can see in here a new window appears, and this is the information that we get so far. An array has been inserted in the method search in here. I call the class, it's a constructor, call the class, and the method has been here called. And based on this information, I have an array from -1 to 212. These are the elements. And the target of 34, which is an extra information. These glasses is a watch out, look out, whatever. It's like anticipation, because like we have the num length equal to 0, and this is 14, and 14 is not equal to 0, so we just continue our code. We click the step over in here, click it. Right now we are going to initialize left equal to 0, and then right equal to nums of length, which is like 14 minus 1, that is 13. While left less than or equal than right, left is 0 and right is 13, we continue looping this statement in here. The first statement is the midpoint, which is equal to the left plus right minus left divided by 2. Left is 0, right is 13 minus left divided by 2. Why this code not just like, well, we can just like the midpoint by like right divided by 2. There is integer overflow. There is so many integers that Java can have. It's like 32-bit. You Google it yourself. But this is the safer code to prevent the integer overflow. When you hover it, you can see in here, or you just click it. Yep, it shows 0. What is 0? That's our left is 0 in here. And then when we hover in here, right is 13, and we hover here, left is 0. So when you hover that element, you gonna know what's inside it. So right now 0 plus 13 minus 0 divided by 2, that is 0 plus 6.5. And we round it down, so that is basically 6. Our midpoint is at the index 6. We click the step over, that's it. The midpoint at the index 6, and the number at the index midpoint at the index 6 is 21. 0, 6, that is 21 in here. Does the 21 is the target that we are looking for, which is like this statement in here? It is not. If it is yes, we return midpoint. If not, we move to this statement. And then we move it. Does the midpoint, which is like the number at the index of midpoint, does 21 greater than target 34? It is not. So we skip it and move to the next statement. Else, left is equal midpoint plus 1. What does it mean? The midpoint is in here, 21, and there is no way our target is before this point. There is no way our target in here, because that's binary search. So we can just focus moving forward. So previously, this is our left, which is like at index 0, and right at the index 13. We just move the left pointer from the index 0 to index 6 plus 1. So we will have our left pointer at this number at the index 7. That's it. That is our first iteration. Then we check again, does our left equal less than or equal to right? The answer is yes. So yes, we just execute the next statement. what is this? The next statement is the midpoint. 7 plus 13 minus 7. 13 minus 7 is 6. 6 divided by 2 is 3. So 7 plus 3 is 10. I should be correct. Yes, it is 10. And index 10 is at the 55 in here. 13, 12, 11, 10. Cool. Right now, does this number equal to our target? Nope. We just move to the next statement. Does our target 55 greater than 34? Yes. So we have to shift the right pointer to midpoint minus 1, meaning that our target is less than the midpoint. There is no way our target is greater than 55. So we don't really care about any array beyond 55. We want to care about the number before or behind 55. I don't know the English. You know it. So right now, the midpoint shifting from 13 into 10 minus 1, which is 9. That's our right pointer right now. With the left pointer 7, right pointer is 9. So we continue. Does our left still less than or equal to right? That is true. 7 is less than or equal to 9. Cool. So we check our new midpoint. The midpoint is 7 plus 9 minus 7 is 2. 2 divided by 2 is 1. 7 plus 1 is 8. So that is our midpoint. What is the index 8? Index 8 is 26. The number of 26. Index 8 number of 26. Is that our target? Nope. Is 26 greater than 34? Nope. So we just move the left pointer by 1 from the midpoint. The midpoint is 8, so left pointer is 8 plus 1 become 9. Cool. Right now, left less than or equal right. So that's the iteration done. We go to the next iteration. I don't know how many iterations right now. We just keep going. We don't really care until the condition are met, which is like as long as this is true, we keep going, and this is still true, we keep going. So right now, the midpoint is 9 plus 9 minus 9 divided by 2. 9 plus 0, 9. That is our midpoint. Is that our target? Exactly, that's our target. So we execute the statement in here. This is the midpoint, and this is the same with our target. So right now we have the target 34 at the index 9, and if we go back to this code in here, we through return midpoint, this is the return statement, we will return that index 9 number, and it's shown in here as not in here. Yeah, the result is 9, and we check with the expected, which is like the expected is 9 and the result is also 9. So let's get our result, and that's how we end this code. And that is how the binary search tree work on the background. Yeah. What else? Yeah. Hope.